So in order to solve one of these, the thing that tells me which technique to use is actually the fact that in this equation I have both an x squared and an x in there. And because I have both of those, that tells me I cannot solve it just by like moving the 20 to the other side or something like that. Instead, I'm going to have to factor it. So I'm going to have to write this into factored form, which means what two numbers add to the negative 9 and multiply to the 20? Yep, it is negative 4 and negative 5. So we write it in factored form first. So you should have x minus 5 times x minus 4 equals 0. Now keep track of that equals 0. I do see on a lot of people's paper they tend to start leaving that off. You can't leave it off. You got to keep it there. Because now that it's factored, we can now say what x is going to make it equal 0. So what minus 5 equals 0? What minus 5 equals 0? Well, x minus 5 equals 0. Solve it, so we add 5 to both sides. And you should end up with x equals 5. Similarly, what minus 4 is going to equal 0? And so for that one, we go x minus 4 equals 0, and we solve that. So that means adding 4 to both sides of the equation. And so you end up with x equals 4. And so that's that process for the first one. The second one, you notice, is set up in the same kind of way. So you're going to have to solve it using the same methods. So go ahead and go on to the second one, factor it, then solve it. When factoring the second one now, a little bit of a clue here. We're multiplying to a negative. How do we multiply to a negative? A positive times a negative, absolutely. So you can already know that when you factor it, it's going to be 0 equals x plus something, and there's going to be an x minus something. So you already know that one's going to be plus, one's going to be minus. So keep that as a clue as you're looking to see what multiplies to the negative 12 and adds to the 4. All right, so that factored form is 0 equals x plus 6 times x minus 2. Again, on your paper, make sure you actually wrote the 0 equals part, because unless this equals 0, we actually couldn't go anywhere from here. All right, so what plus 6 equals 0? In order to figure that out, we end up actually doing x plus 6 equals 0 and solving that. So we subtract 6 from both sides. So we find that x equals a negative 6. And then for the x minus 2, we see what makes that equal 0. So x minus 2 equals 0. Solve that by adding 2 to both sides. And so you got x equals a positive 2. So, a little quick refresher there, solving quadratics. Let's start with both the x squared and the x in it. Factor it first, then set each of the factors equal to 0. Next up, we're going to be practicing the graphing that we were taking a look at yesterday. So take out the graphing grids we were using yesterday, and then write down this equation and go ahead and make the graph of it. And so yesterday we introduced these problems that had the negative sitting out front of it. But remember that the negative doesn't actually affect where the first point goes. So the first point is still determined by this minus 2 and the plus 8. The minus 2, it's in with the x, so that tells me it moves it in the x direction. More specifically, a minus is going to be moving it to the right. So we're going to be going right 2, and then the plus 8, that tells me that it's going to be going up 8. So our first point is over there at 2, 8. Then from there, the negative affects where we go. So the negative tells us that we are not going to be actually going upwards for this graph. The negative tells you to go down instead of up. So your eventual graph is going to be looking kind of like this kind of a shape, because it's x squared. It's that U-shaped graph, the parabola. But of course, those aren't the exact points. Please plot the exact points if you haven't yet, and then we'll take a look at where those would be together. To plot the actual points then, whatever we go over, we square that to know how far to go down. So 1 squared is 1. So I go over 1 and down 1. 2 squared. 2 squared is 4. So that means over 2 and down 4. Okay, 3. What's 3 squared? 9. So over 3, down 9. Can I fit the next one on? If I go over 4, what's 4 squared? 16. So that'd be over 4 down 16. Yes, that is going to fit. So we go over 4 down 16 to get to that point. Over 5 would be down 25. Yeah, that's not going to fit. So that's all our points that we can actually plot. Go ahead and draw the curve that goes through it. Make sure that is solid on your paper. All right, next up, I'd like you please on your scratch paper to write down and solve this equation. So first up, remember that we're going backwards through the order of operations, so I want to get rid of any addition or subtraction first. I can't get rid of the minus 2 because it's trapped inside the square root, but I can get rid of the plus 8. So subtract 8 from both sides. So the next thing is then to get rid of the negative that's sitting out front of the parentheses. Now what do we do to both sides to get rid of that negative? Yes, exactly. We divide it by -1. And then once we've divided by -1, this problem now looks like a lot of the problems that we had seen previously. Next step, get rid of the squared. So in order to get rid of the squared here, what do I need to do to both sides? Square root. Yep, so we square root both sides now. Now the tricky part when taking the square root of both sides is that you have to remember that plus or minus on the other side. So when I take the square root of both sides, the 9 becomes both a 3 and a -3. And so I got 3 equals x minus 2 and -3 equals x minus 2. Solve each of those by adding 2 to both sides. You should find that x equals 5 and -1. As always, please make sure that's correctly written on your paper. That way, should you see one like it in the future and you get a little stumped, you have a correct reference to look back on. And then the last thing I want to go through on this is actually combining these last two problems that we did. Because did you notice that this part of the equation over here is exactly the same as the one I had you graph earlier? I want you to see a connection between the solutions that we just found and the graph that you made. So you'll notice that we're solving this equation up here, and it told us that x equaled a -1 and 5. You can actually see those come up on the graph as well. Because what we're looking for is we're looking to see when the y was -1. Notice y is -1 right here. And where is the graph hitting that -1? Notice the x-coordinates are -1 and 5. So when we're solving these equations, it's even telling us something about the graph. It's telling us where that graph is actually hitting that particular y value that we are looking for, in this case the -1. And so if you have the graph, you could even use that. Like, really quickly, could you tell me what the solutions to this whole equation would be if y equaled 7? Well, it'd be the x-coordinate of that point and that point. So it would be at 1 and 3. And so the graphs and the algebra you're doing are all interrelated. We just tend to treat them separately at first because we're getting used to each of them. But being able to see how they connect will be really useful going forward.